Take a look at this domain question. When students see layered log structures combined with a fractional absolute inside a sine inverse function, they expect pages of tedious inequality shift. This is an absolute illusion. If you process this systematically from inside out, the properties do all the heavy lifting for you. So let's think sharp.
Hey thinkers, welcome back to Think Sharp Alley, where every turn leads to a smart solution.
Here the given function is this. Now to find the domain of this function, we must find the intersection of the domains of both major components. So let's divide this sum into two parts. Part 1, where we will solve the nested logarithmic part. Now for a nested log function to be defined, for example, for log x to be defined, the argument inside the log, that is x, must be strictly positive. Log base 3 will be defined if the argument, that is highlighted in green color, must be strictly positive. Since the base of this log is 5, which is greater than 1, we remove the log without reversing the inequality over here. So we get 5 to the power 0 on RHS. Now 5 to the power 0 is 1. And 1 minus 7 is minus 6. And when I cancel minus sign from both sides, the inequality sign changes. So we get log, that is LHS part, less than 6 now. Now please note here, for log base 2 to be defined, the argument x² minus 10x plus 85 must be strictly positive. So let's check whether it is true or not. So this inside argument can be rewritten as x minus 5 whole square plus 60, which is strictly positive because it is always greater than or equal to 60. So you see, its individual log constraint is trivially satisfied for all real numbers. Now once again over here, we have log with base 2, which is greater than 1. The base is greater than 1, which means we can remove the log. So we get x² minus 10x plus 85 less 2 to the power 6. 2 to the power 6 is 64. So when it comes to the left hand side, it gets subtracted. So we get 85 minus 64, that's 21 less 0. Then we factorize this quadratic equation using middle terms trig, and we get x minus 7 into x minus 3 less 0, which means x lies between 3 and 7. Let's consider this as condition 1. Now let's move to part 2, where we solve the inverse sine part, which is this. Now remember, for sine inverse x to be defined, modulus x must be less than or equal to 1. So over here, in place of x, I have this fractional argument which is already in modulus. So which means this argument must be less than or equal to 1. We only care about the values of x that also satisfy condition 1. We can simplify the absolute value bars by evaluating the signs in this specific interval. So let's consider the numerator first. Since x lies between 3 and 7, and multiplying by 3 throughout, we get 9 less 3x less 21. Then subtracting 7, we get 3x minus 7 lying between 2 and 19, which means clearly numerator is greater than 0. Now let's have a look at the denominator. For denominator, we need 17 minus x. So let's change the sign throughout. So we get minus 7 less minus x less minus 3. Then adding 17, we get 10 less 17 minus x, and 17 minus 3 is 14, which means clearly denominator is also positive because it lies between 10 and 14. Because both the numerator and denominator are strictly positive on our target interval 3 to 7, we can completely drop the absolute value bars. So we get this. And remember, denominator is 17 minus x, which is already greater than 0. So we can cross multiply without changing the inequality sign. This gives me 4x less equal to 24, and that gives me x less equal to 6, which is our second condition. Now comes the part 3 of this question, where we'll take the intersection of both the condition 1 and condition 2. So combining both the conditions, we get x is between 3 and 6, because clearly x less equal to 6 and 6 is already less than 7. So which means the common portion over here is 3 to 6. So if I write in interval format, I will get x belongs to open interval 3 because it is strictly greater than, and here I'll get close interval 6 because we have less than equal to. So if I compare this with our question, alpha's value is 3, beta is 6. So alpha plus beta is equal to 9. The correct choice over here is option A. Using your first condition to simplify subsequent constants keeps your working extremely fast. If you got 9 as your final sum, drop a thunder in the comment section below. Subscribe to Think Sharp Ali and let's conquer question 18 next.